Hello, youngsters. Welcome back. It is the in-school session of Let's Do Some Solving Rational Equations. So, section 6.5 here, we're going to take all that stuff we've been doing and we're going to solve. So, some key ideas when you're solving rational equations. First of all, we're always going to determine the NPVs first. Okay, this one is a simple phrase, but this is the meat of the entire lesson here. To multiply both sides by the equation by necessary terms. So what I mean by necessary, I don't mean to cross out, I mean to underline it. What I mean by necessary terms is whatever it takes to remove the variables from the denominators. We'll talk about this more, as things go on. You're going to solve the equation, you're going to check that the solutions are permissible. This is really key because if you get a solution that is not permissible, it's extraneous, and we've seen this before in the radicals unit, especially. So here's a simple little example. You got 5 over x plus 6 over x squared equals 6. So my big summary of today is, see these guys? That is bad. Okay, you do not like your variables in the denominator. So how do we get them out of there? We have to follow the rules of math, so we can't just get them out. We have to multiply both sides by something. So this is that idea of what's necessary. So whatever's necessary here, we will multiply both sides by, let's see, I'm just going to write it over here. So we've got 5 over x plus 6 over x squared equals 6. I'm going to multiply both sides by x squared. The reason I'm going to multiply both sides by x squared is because x squared will multiply into each one of these terms. It will eliminate this x on the bottom, and it will also eliminate this x squared on the bottom. I cannot just multiply by x, and if I multiply by something bigger like x cubed, that's sort of overkill. And of course, this side also needs to get multiplied by x squared just to keep everything fair. When I multiply x squared in with 5 over x, this becomes 5x squared over x, and then the other guy becomes 6x squared over x squared, and then the other one becomes 6x squared. Okay, so at this point you can start crossing things out, and a lot of you are going to want to just skip this step, and that's not even that big a deal. You can cross those out and cross those out. So we're left with 5x plus 6 equals 6x squared. Now I got really excited. I forgot to do my NPVs. Just don't forget, you can always go back. My non-permissible values, of course, is just x is equal to 0. So for both of those. That's important because when it disappears, if you look at this equation, it doesn't look like it has any non-permissible values, but it definitely does. Okay, so how do we solve this guy here? We're going to make this look like 6x squared minus 5x plus 6, and we need to see if we can factor this. Is this a factorable thing? I think it is. I think this should go 6x squared. I want to say, let's see, AC equals 36, B is equal to -5, so I think 9 and 4 will, negative 9 and 4 will do the trick. So negative 9x plus 4x plus 6. And we go ahead and we get 3x, so that's 2x minus 3. That's plus 2, so that's 2x. Oops, I made a tiny mistake. That should be negative. That's why things weren't working out. There we go. That's better. Okay. So what we wind up getting is we wind up getting 3x plus 2 and 2x minus 3. So this tells me that x is equal to negative 2 over 3. And then this one over here tells me that x is equal to positive 3 over 2. Now, of course, so we just solved that. Quite often you're going to end up with a quadratic equation. Not always, but quite often. And none of these are the non-permissible value of 0, so it turns out that they're both real, and they're both real. You don't have to write they're both real solutions, but I'm just going to write here just to be very clear. Okay, so they're both real solutions. Awesome. Okay, here's another example. So we've got this one here. Now, I know a lot of people have seen these kinds of equations before, and some of you are going to be tempted to take shortcuts, and that's not even that bad, but I want you to understand what you're really doing. One shortcut is to take this and move it up here, take this, move it up here, and you're essentially doing some sort of cross-multiplying thing. But I'd really like to emphasize here, that's not really a thing you can do in math. That's the shortcut of some actual proper math, and let's look at the proper math before we start shortcutting things out. So the first thing we're going to acknowledge is x cannot be equal to -2 here, and x cannot be equal to 3 there. What do you have to multiply both sides of the equation by to get rid of what's necessary? You want to get rid of x plus 2 and you want to get rid of x minus 3. So the proper thing to do is to multiply both sides by x plus 2 and x minus 3. And you do that on the other side as well. By multiplying by both of those terms, you're ensuring you're doing the same thing to both sides, and you've got a canceling factor on either side. So what happens here is the x minus 3 and the x minus 3 cancel, but the x plus 2 is left. The x plus 2 and the x plus 2 cancel, and the x minus 3 is left. So that is the similar result to just taking x minus 3 and moving it to the other side, but it's not cheating. All right, so what we're left with is -3 times x minus 3 equals 2x times x plus 2. This should be pretty easy to solve from here. We'll do it, but this is kind of a routine thing now, so let's just go ahead and wrap it up, and I hope I don't make any silly mistakes. Okay, so we add 3x to the other side, so we get 7x, we subtract 9. I think this is factorable, 18. So AC equals -18, B is equal to 7, so it looks like a 9 and a 2 will work. It's going to be 9 and a -2. Plus 9x minus 2x minus 9. And from here we'll go, let's factor out what we actually can. Let's factor out an x. 2x plus 9. We'll factor out minus 1, 2x plus 9. Okay, so my two answers are x minus 1 and 2x plus 9. Sorry, my two factors. And that tells me that one of my answers is x is equal to 1, and the other answer is x is equal to -9/2. So I can see that my non-permissible values were -2 and 3, and since neither one of those is a non-permissible value, they will both be real answers. And it wouldn't be a bad idea to actually stick them back into the original equation and give it a shot. And you could do it real quick if you want. You could even check. I'm not going to check both of them. I'm going to pick the easy one here. Check x is equal to 1. And it's not a bad idea just to check that, this actually all works out. So are these the same? This is this side's -1, and this is 2 over -2, which is -1, and everything's good. And you could do it with -9/2 as well, but that's a little bit more work, so I'm just going to go ahead and skip it. Okay, here's another one. So what do you have to multiply both sides by to get the variables out of the denominator? In this case, you can see you've got a trinomial, so you definitely want to be factoring this to see what's what. And you're actually going to factor it also to find the non-permissibles. So this one looks like it's not too bad. I think this is x minus 5 and x minus 3. So we can actually see there's an x minus 3 on both sides. It's going to be tempting to just cross them out right away, but I'll again ask you to not go ahead and do anything that you're not allowed to do. You're not actually just allowed to cross things out. It's the result of proper things like multiplication, division. Okay, so what do we multiply both sides by? You are going to want to multiply both sides by x minus 5 and x minus 3. Okay, that will cross out with this guy here, and this one will cross out with that guy there, and this one will cross out with that guy there. So we are left with, at the end of this, x times x minus 5 equals -6. And then solving this is pretty routine, so we'll just go ahead and do it real quick. Okay, so this becomes x minus 2 and x minus 3, and we get our two answers, 2 and 3. Okay, so now let's see. Compare it with our non-permissibles. Gasp. non-permissible x cannot be equal to 3. So that means that this guy, x is equal to 2, that's real. This one, that is extraneous. You cannot have x equals 3 as a solution. So the only solution, therefore x equals 2 is the only solution. All right. Okay, and finally the big daddy of the whole thing here. If you have not had a chance to try one, why don't you pause the video and give it a shot for yourself. Okay, so what do we have to do here? X plus 1 over x plus 6. You're not going to do too much to the left side, but you're definitely going to want to factor the right side. So two numbers that multiply to 24 and add up to 10. Oh, that's interesting. That's x plus 4 and x plus 6. Okay, so when I multiply both sides, and this is important, make sure you put fatty brackets around the whole thing. X plus 6 and x plus 4. This side is also going to get multiplied by x plus 4 and x plus 6. I guess before we get going too far, let's find our non-permissibles, negative 6 and negative 4. Same thing with the other side. Okay, so what happens when I multiply this in? So one mistake that people make sometimes is they want to selectively take one of these factors and multiply it in with the first one, and then the other one gets multiplied in with the second one. No, that ain't what happens. What you've got to make sure you do is you've got to make sure you multiply both of them in. Whoops, I erased too much by accident. Okay, so this entire thing gets multiplied in with both of those. So the way this works is you've got x plus 1, and then you've got it multiplied by x plus 6 and x plus 4, and the whole thing's over x plus 6. And then you've got the other guy. I guess that should have brackets around it. Okay, so just the big moral of the story here is don't just take individual terms in there, multiply both of them in. And then on the right side, we don't need to show much because the x plus 4 and the x plus 4, x plus 6, x plus 6, they all cancel out. So showing it the long way, you get this. Now, of course, you can cancel this guy with this guy, but you see the x minus 4 is left over, and the x plus 4 and the x plus 4, and that leaves the x plus 6 left over here. Okay, so we've got x plus 1 times x plus 4, so this is x squared plus 5x plus 4, and then this one is x squared. I'm just doing the foiling in my head, so let's see, minus 2 plus 6, so that's plus 4x, and then that's minus 12 equals this guy over here. Pretty straightforward from here on out. You've just got to collect like terms. So this is, let's see, 2x squared plus 9x minus, let's see, 4 and 12, negative 8. So this becomes 2x squared minus 2x, and then we'll subtract that. So we got 40 over here. And I'll divide everything by 2 because it's just easier to do that. And then we get, what's this, x minus 5 and x plus 4. So what we get is x equals 5 and negative 4. So we go ahead and we look at the non-permissibles again, and we can see that this guy here is real, and this one here is the extraneous dud. Okay, so therefore x equals 5 is the final solution. Okay, so there's some examples. Today was a pretty straightforward little lesson here. Just remember, it's really, really, really bad to have variables in the denominator, multiply by whatever it takes to get them out of there, and then generally becomes a typical equation that you just have to solve. Usually quadratic, but not always. don't forget to check your non-permissibles. Okay, thanks for watching. Goodbye.